Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. So basically, first of all, I will give you an announcement for our upcoming online training program on Google Earth Engine. It will be start from the 8th September and it will last with the 5th September. Okay, and total 7 days online training program, and this class will be start from the 8th September. And if you want to join this online training program, just simply contact with this WhatsApp number as well as contact with this email. Mainly this online training program, we are focused only for the beginners who don't have any knowledge about the Google Earth Engine or who don't have any knowledge about the JavaScript program information and easily join. Okay, so let's go. Okay, so can you hear me? Hello. Okay, just we are waiting 1 or 2 minutes for joining all of those other participants, then we will start. Just a minute. Okay, so hi and hello everyone. Welcome to the 7 days online training program on Google Earth Engine. So basically, today is our fifth number of class, and today I will try to discuss about that how we can easily use the remote sensing for the air quality monitoring. Okay, so using the Google Earth Engine platform, how we can easily use it for that air quality monitoring, different types of parameters, how we can easily access using the remote sensing technique, such as sulfur dioxide, carbon monoxide, or methane. Okay, all of those gases, how we can easily access using the remote sensing technique, and also make the time series chart and also calculate it for a specific area how much nitrogen dioxide gas or carbon monoxide gas is emitted in a particular time. Okay, and also make the time series chart about that. Okay, so let's go jump in our today's class. So just I simply share my screen. Okay, so can you see my screen now? Okay, so let's go our class. Okay. So basically today is our fifth number of class, and mainly today in this class I will just try to discuss about that air quality monitoring. Okay, so how we can easily monitor the different types of air quality parameters using Google Earth Engine platform. Okay, and also make the different types of air quality parameters, distribution map or density map, as well as how we can easily calculate it for any specific region, how much gas, any particular gas, how much gas is emitted in a particular time period. Okay, and also make the time series chart about that. Okay, so you can see all of the sports I will try to discuss for the today's content. First of all, nitrogen dioxide, sulfur dioxide, such as also carbon monoxide or methane, all of those gases which are available in the Sentinel-5 satellite sensor. All of those gases, I will try to show you that in this time. And after that, how to download the air quality parameters time series data in CSV file format, okay, or Excel file format. So mainly CSV file format, how we can easily download the air quality parameters time series data in CSV file format, and how to convert this unit mole to meter to molecule to centimeter cube, as well as how to make the time series chart of this air quality parameters, and finally how to export this map and use ArcMap software. As well as I also show you that how we can easily calculate it, any particular time period, how much nitrogen dioxide gas or carbon monoxide gas is emitted in a particular time period, how much gas is emitted. Okay, so first of all, here you can see the two example about that nitrogen dioxide and methane gas concentration map. So first of all, it's showing the methane concentration map of Kuwait, and mainly in this time this unit is the ppb unit, and we can easily identify where the highest concentration of methane and where the lowest concentration of the methane. From this map we can easily visualize this result, as well as we can also get that another map in here. It is the nitrogen dioxide concentration map, year of 2020, month of January. So mainly in this time, this type of color, blue color, is identify about that nitrogen dioxide gas, and it's a high concentration. Okay, it is a high concentration, and in this time this unit is that mole per meter square. Okay, as well as we are also get the some low region. You can see this is the this type of color, a yellow color, showing that low density of nitrogen dioxide. Okay, as well as also you can see this is another map about the nitrogen dioxide level rebound in Bangladesh for the different time period, such as before lockdown, during lockdown, and post lockdown. And we are also classified where the very low region, where the low region, medium region, high region, and very high region. Okay, so basically all of those things we are use the Google Earth Engine platform for creating this type of tip images, and finally we create this type of map we create using the ArcMap software. Using the ArcMap software we just create all of those things, but our main data analysis we take using the Google Earth Engine platform. So in this time mainly we are using the air quality monitoring using the Sentinel-5 satellite imagery. So this Sentinel-5 satellite imagery, from that we can easily access the different types of data products such as ozone, nitrogen dioxide, sulfur dioxide, formaldehyde, aerosol, carbon monoxide, methane. So all of those gases we can easily access from that Sentinel-5 satellite imagery. And this is the link about the dataset. So simply go to this link. It will be open all of those Sentinel-5 dataset. Okay, so in this time I just simply open my code editor and try to show you that how we can easily access that dataset. Just continue. Okay, so in this time, I simply click on this search bar and you can see browse data catalog, click on here. So now it appeared all of those data set. From here, I just find out the Sentinel imagery. In this time, I work with Sentinel-5 satellite imagery. So just I simply find out the Sentinel-5. Yeah. So basically in this time, we are using at this data set, Sentinel-5 Tropomi. It's mainly tropospheric monitoring instrument. And it availability for year of 2018 to present time. Okay. So just I simply click on here. So here I can get all of this information about that. So here you can see, so mainly from this data set, we can easily access the aerosol index, UV aerosol index, cloud, as well as also you can see the carbon monoxide, also access about the formaldehyde, and also nitrogen dioxide, then ozone, and also sulfur dioxide, and also methane. We are access from that Sentinel-5 satellite imagery. Okay, so in this time, all of those data set is the same approach when you want to visualize and make the time series chart or other types of analysis. So in this time, I simply choose, suppose I will simply work for that, suppose methane. Just simply click on the methane. So now I can get all of this information about the methane. Okay. So here you can see mainly this the methane. We can get the dataset from year of 2019, 8 February, from 2023, 806. Okay, this is the present time. We can get access this dataset between this time period. And this dataset provider is that European Union, ES Copernicus. And we can check all of this information about the dataset. This dataset resolution is that 1113.2 meter. Okay, it's the pixel area of this dataset, as well as also you can get about that description about the dataset. So mainly what is the algorithm they are used for extract the information such as methane. All of those things we can get from here about the dataset information. Okay, as well as we can get the some band. You can see it is the methane column volume mixing ratio, dry air, and the mole fraction. You need the mole fraction. Okay, so in this time I use this data set and try to find out the methane concentration or methane density. So for that, first of all, I need to import the data set into my code editor. Okay, so for that I simply copy this RTL snippet from here. Simply copy and then paste in my code editor. Okay, then give a variable name. Suppose I put the variable name is that, suppose data. Okay, you can put any variable name, there is no problem. So I simply import my data set in here. So in this time, this data set I need to filter. Okay, so mainly when you can see the image collection, so mainly when I can get the image collection, this image collection I need to filter for my specific region, for a specific time period, for a specific condition. So in this time, basically this data set has a lot of band. You can see this data set has lot of band. It also available for the aerosol height, aerosol optical depth. So a lot of things available in this data set. In this time, I want to work only for the methane column volume mixing ratio dry air. So for that, I simply copy this band name, a specific band name, simply copy, and then use a function, select function, and then paste here. Okay, just I simply select the specific band of this data set. Okay, so basically this image collection available for the whole time period, year of 2019 to 2023. Okay, but I need the data set for only for the specific time period. Okay, so for that I need to use a function, this function called the filter date function. Okay, in this time I simply import here my start date and end date. Suppose I put here the start date is that year of 2020, 1st January, such as I put the time such as year of 2020, suppose January 31. Okay, I take only for the 1 month data set. Okay, so after that, if I want to check how many images I can get from here, so simply use the print function and print the data and use here the size function. So now click to the run. So now with computing, we can get the 297 images for the 1 month of it means year of 2020, month of January. I find out total 297 images, and this 297 images for the whole globe, whole world. Okay, not for the specific area. Okay, so in this time, suppose I want to visualize the methane concentration map for the whole world. Okay, I want to visualize the map
Sure.
for, yeah, please.
Can I,
Yeah, please. Yes.
can you change the color of your black color of your screen? I can't
Okay, just a minute. Okay,
see
okay.
it.
Okay, so yeah. Okay. Okay. Okay, sounds okay. Okay, now you can see here you can get the 297 images for the whole world or globally. I can get this 297 images. So in this time, of methane concentration for the whole world. Okay, so for that, these 297 images I need to reduce. Okay, so mainly we use the reduce to create the average, maximum or minimum. In this time I calculated the average density of methane for the whole world. So for that I need to use at the mean function. Okay, so now how we can get the mean function? I simply take a variable. Suppose put the variable name is that suppose average cs cs4 or methane. You can take any variable name. These 297 images stored in a variable. This variable called the data. I simply copy the data. Okay, and now I want to reduce it. Okay, so for that use at the reduce function, reduce, and put at the e dot reducer dot mean. Okay, so now it calculated the average pixel value of from the total 997 images, create the average pixel value and create this image. So now display this. So use at the map dot add layer. I want to add a layer of average methane. Simply copy that. Okay, so now click to the run. So now it display the layer about that whole world methane concentration map, year of 2020, month of January. Okay, in this time I can get that this type of color. You can see white color. Okay, so in this time I just set the color. For that I simply copy their default color code. You can see this is the default color code. I simply copy from here and paste this color code in here, and then simply copy the variable name, and this variable name just paste after the object name. Okay, then click the run. Okay, so now we can get the result look like that. You can see. Okay, so methane. So in this time this red color identify the high concentration and black color identify the low concentration of methane. Okay, and in this time we can get some place. There is a no, suppose in this time we can get that there is the no data for this place. Okay, we can get there is the no data in this time. For suppose in this time there is the no produce about the methane gas, so that's why this type we can get some empty place in here about that place. You can see, I zoom it. Suppose in this time it's showing only for that month of January. So I also increasing the, suppose I simply increasing the date about that. Suppose I put here that February, also January to February, 2 month data I check about that. Okay, so in this time it will be just 28 February. Okay, so I simply put it. We can get the 690 images in this time. Okay, so now it calculated the average result from 690 images. Okay, you can see. Okay, so in this time it's showing the result for the whole world, month of January. Okay, so in this time I need for a specific country or a specific place. So for that I simply import the boundary shape file from the asset tab. Suppose I simply import the Bangladesh country boundary shape file and then use it that put the variable name, suppose ROI. Okay, and then this ROI I just simply use here clip function, clip with ROI. Okay, now click to the run. In this time I can get the result only for the Bangladesh country boundary. Now we can check about the result for the Bangladesh country boundary. Okay, so in this time here you can see it showing the result look like that. So basically methane is the hydrocarbon that is primary component of the natural gas, and methane is also the greenhouse gas. Okay, so it's the present in the atmosphere affect the earth at temperature and climate system, and methane is emitted from a variety source. Okay, variety source, it can be anthropogenic or human influenced or natural sources. So basically we can see the in this time you can see mainly the this type of forest. Okay, you can see this the mangrove forest, this region also you can get this type of region. Okay, it's the very there is the no gases or there is the no pixel value about the methane, but we can get this type. You can see this is the Dhaka city region, you can get the pixel value about the methane, and also you can see there is the river. You can see this is the river, so there is the no emitted about that methane. Okay, so basically methane is the emitted from the variety of anthropogenic and also human influenced it also happened for that created the methane. But in this time you can see there is a river, there is no pixel value about that. Also there is the forest, it also have some but not much. You can see the mangrove forest of Bangladesh, not much about the concentration of the methane. Okay, in this time it showing the data only for the January and February 2 months. Okay, suppose I also increasing the time frame, then we can also get the better result. Suppose I put at the January, February, March, suppose May. Okay, suppose 30. So now click to the run. So now we take the image between this time period and create this map. Can get the total 1899 images between this time period, and now it's create the 189 images average pixel value and create this map. It working? Yeah. Okay, so now you can see it will appear about the result. Okay, you can see. Okay, so now we can get the result from the January to May. Okay, all of this month it create the average pixel value of methane. Okay, so mainly in this time we can get this map look like that. So in this time you can see the forest region, there is very low concentration, such we can get in here, but other part there is the no pixel value about the methane. And also you can see river, there is the no, also you can get there is the no. Okay, so basically methane is emitted from a variety of anthropogenic or human influence. Okay, and mainly anthropogenic emission source, it can be including the landfill, oil or natural gas system, agriculture activities, as well as also coal mining, or stationary and mobile combustion, as well also wastewater in treatment, okay, and industrial process for creating the different creating the methane gases. Okay, so in this term we can get the result look like that. Okay, and mainly forest are very low we can get, and also you can see river, there is no about that, also there is no in here for this forest region. Okay, so this is the map about the in January to April. We can get this result look like that. Okay, so now in this time I want to create the time series chart. Okay, suppose in this time I want to check when the methane concentration is the high or when the methane concentration is the low between this time period. Okay, so in this time I can get the result look like that, and from that we are also make the some classification or other things. Okay, so in this time I just show you that how we can easily make the time series chart about that. Basically between this time period when the concentration is the high, when the concentration is the low, we can easily create the time series chart from here. Okay, so let's go. Time series chart, simply use a function ui dot chart dot image dot series. Okay, and put all of those argument one by one. First of all, image collection. Image collection means that how many images create this map. Okay, how many images create this map. In this time this map create 1899 images. Okay, so this 1899 images is stored in a variable. What is the variable name? Variable name is the data. Simply copy the data, this variable name, copy and paste here. Okay, then region. So mainly region is your boundary area. In this time my boundary is the Bangladesh country boundary. Okay, and it is stored at the variable name is the ROI. Okay, just simply use here the ROI, and I create the time series chart for average pixel value. Use here the EE dot reducer dot mean. Okay, then scale. Scale is the resolution or pixel area, 1113.2 meter. And X property, so it's the default we are using here the system time start. Okay, so now in this time I just simply print that, print, and also print in here for close the parenthesis, and now click the run. So now it creating the time series chart. And from this time series chart,
Can I interrupt?
yeah, please.
From where you get the scale value, the 1000 something?
Okay, so I can get it from the image information. You can see. Simply go to this. You can see the resolution. Okay, it is the resolution number. Scale is the resolution number.
Okay.
Image dot 1113.2 meter. Okay. So now it's generating the time series chart, but sometime this time series chart is not generating. When it will be across the limit of 5000 element, then this chart is not work. Okay, then we have also need to apply the another method. Just we can directly download the data in Excel file or CSV file format. Okay, we can easily download the data in Excel file and CSV file directly in Google Earth Engine platform. Suppose I in this time I create the time series chart, and from this time series chart I can easily download the CSV file format. But Google Earth Engine is also possible directly download the Excel file or CSV file. So you can check what happened this time. Okay, so in the meantime I also try to discuss about the another gas. Okay, so it will be working. Done. Okay, so in this time I talk about that suppose another gas such as suppose nitrogen dioxide. Okay, so for that what can I do? Just I simply use the nitrogen dioxide, click on here. Here I can get all of this information about the nitrogen dioxide, availability, date or time period, dataset provider, Earth Engine snippet, all of those things I can get in here. Just apply the same approach. Okay, just apply the same approach. For that what can I do? Just I simply copy all of those code from here and open a new code editor. and then paste the code, all of those code paste in here. In this time I simply change. I change the, you can say, I simply copy this, I simply copy the art in the snippet for nitrogen dioxide, simply copy that and change in here. I simply change it, as well as I also need to change the band. Okay, in this time I want to work for the band of nitrogen number, column number, density. Okay, and this unit is the mole per meter square. Just I simply copy that and then simply change the band name also. Change the band name. I simply change the band name. Remove that and then simply paste here. Okay, and then I use the same time period about that. Okay, so now, okay, so then simply check all of those things will be same. So now when I, okay, I also change the visualization parameter also. In this time I simply copy the visualization parameter from this data set. Simply copy and paste here. Okay, so in this time when I click to the run, I can get the result. Okay, I also need to import the Bangladesh country boundary shapefile also. So go to the asset tab and you can say simply import that and give the variable name is that ROI. So now click to the run. In this time I can get the result about that nitrogen dioxide concentration map of Bangladesh from January to May. It working. And I also try to use that, suppose map dot, simply the map dot center object function for focusing the center of the shapefile ROI, suppose 10. Okay, so I simply use the, suppose January 1 month, because for the net connection is the slow, so that's why it takes some time. Okay, just I use the 1 month data set and then try to show the display the data. Yeah. Okay, it appeared. Okay, yes. Okay, so in this time it's showing this type of result only for the nitrogen dioxide concentration map month of January. Okay, so in this time this red color identify the highest pixel value of concentration of nitrogen dioxide, and also black color identify about that lowest. Okay, so in this time suppose we can get the map look like that, and in this time we can get the highest concentration of nitrogen dioxide for the Dhaka city region. So in this time if you want to check the pixel value about that, click on the inspector tab and click on here. So now I can get about the pixel value. You can see the density is that 0.0023 mole per meter square. Okay, mole per meter square about that. Suppose I simply click on here another thing, suppose this region. We can get this result look like that. Okay, and finally when I export this map as a TIFF format, and I can easily create this type of map, you can say this type of map create using the ArcMap software. Okay, just download the TIFF image and then just extract by marks with my shapefile, and I can simply add all of those legend, title, all of those things we can add and make this map look like that from downloading the TIFF images from here. Okay, so in this time we check about the time series chart, it also working. Okay, same, suppose you want to work with for the another gas such as, also you can see.
Excuse me.
Yeah, please.
Will you show us how to prepare the map in ArcMap software?
Very slow, kindly loudly.
Hello, am I audible?
Yeah, please.
I'm asking that will you show us how to prepare the map in ArcMap software?
Yeah, I show you that. Yeah, I also show you that. Basically, I will show you the next class about that, how we can easily create about the map in ArcMap software
Okay.
after doing the land use land cover classification map, because land use land cover classification map and this type of tip format some different. Okay, so both of things I will show you at the same time.
Okay. I have one more doubt from one of our previous classes. Can I ask you right now or at the end of the class?
What is the problem?
I have one doubt from one of our previous classes.
Yeah, so
So
not
should
yet,
I
not yet.
ask
After
it?
completing the session, you can ask.
Okay.
Yeah.
Okay. Okay.
Yeah. Yeah. Okay, so now you can get the time series chart look like that. Okay, we can get the time series chart look like that about the concentration in high down low between the nitrogen dioxide, and also okay, in this time we can get the error sum here. You can see in this time it will not work. It's showing that error generating chart computation time out. Okay, so this type of problem we can face when I want to work with for the big area. Okay, but it has the another solution about that. We can directly download the Excel file or CSV file from here. Okay, so in this time you can see here when I click on here, I can get the chart look like that. Okay, I can get the chart look like that, and from that we can easily download the CSV file format. Okay, but sometime you also face the problem. Look, this type of problem. It's showing the error generating chart computer time out. Okay, but we have also another solution about that. We can simply download the Excel file from here. Directly download the Excel file. Okay. Okay, so now we talk about that how we can easily download the Excel file. So let's go. And this we can easily apply this same approach for any kind of time series data. When you want to download, just apply the same approach. Okay, all time. Okay. So for that, create. Suppose I create a CSV file. Okay. For creating the CSV file as the time series data. So first of all, in CSV file, I want to create. Okay, so I'll say open an Excel file and show you that. In this time, in this Excel file, I create the two things. One is that a date, another is that suppose a value or value. Okay, so it's showing the one column showing the date, a specific date, and also showing the value. Okay, so in this time, I create the two column in my Excel file or CSV file format. So let's go about that. So first of all, I need to create a function. Okay, I need to create a function. For creating the function, just take a variable name. Suppose I put the variable name is the CSV. Okay. CSV, I put here this function keyword, and then simply put here the image. Okay. I take element name as the img. You can use any name, there is no problem. And then use the curly bracket. In this curly bracket, I just put my argument. In this time, my argument is that I need to create the two things. One thing is that a specific date, and also another thing is the value. Okay, suppose I can get the image for suppose January 1st January 2020. Okay, what the concentration about that on this time? Suppose 0.445, this type of concentration I can get. So this type of result I need to create. So for that I need to create a function, and it also another thing is that you can see here I can get total 410 images. Okay, 410 images have a specific pixel value. So in this time, for that I simply create a function CSV and function variable name CSV, then use here the function keyword and put here the img. In this time I simply put here that my argument, my one argument is that it calculate all of those images average pixel value. Okay, so for that I simply take a variable. Suppose I put the variable name is that stat. In this variable I calculate all of those images average pixel value, and all of those images in this time I consider as a img. So simply copy the img and paste here and use the function reduce region. Okay, reduce region is a statistical, it's mainly calculated the statistically, suppose average, maximum, minimum for a specific boundary. Okay, so here I can get all of those argument. So just I simply make a dictionary and also put here this curly bracket. So first of all, reducer. In this time I need the suppose average result. Use at the ee dot reducer dot mean. Okay, after that geometry. Geometry is the specific boundary. In this time my specific boundary is the Bangladesh, and Bangladesh boundary is stored in a variable ROI. Okay, just use here the ROI. Geometry is a ROI. And scale is a resolution 1113.2 meter. Okay, after that it's not need, I simply remove all of those things it not need. So in this time, from this image I calculate this average pixel value. Okay, as well as I also create another column about the date. Okay, suppose all of those images have a specific date. Here I can get total of 410 images. All of those images has a date. Okay, so for that I take a variable, another variable, suppose date. And this date come from this image also, because which image have a specific date. All of those images has a specific date or time. So in this time I just use here the image, and from this image I extract only for the date. So use here the date function, and date is a number, but when I want to input this number in Excel file, it will be converted into as a string. So for that I use a function, format function. This function mainly convert number to string. Okay, so stat and date is finished. After that I create a dictionary. Okay, so I create a dictionary. So take a variable, suppose I put the date. You can use any variable name and use at the curly bracket. So use at that date and also put here this keyword and key value same, and also do for the stat and also same put here the stat. Okay, so it's a dictionary. In this time, from this function what I return, I want to return this function as a feature. So use here the ee dot feature here the null function, and use here the set with your dictionary. So this is my variable, simply copy date and paste here. Okay, so basically this is the function when you want to create, suppose not only for this data set, any data set, it can be NDVI, NWI, or any time series data. When you want to download as a Excel file or CSV file, just use the same function all time. And before that you need to make the collection. Here I already create the collection, total 410 image collection I already create, and this collection is stored in a variable data. Okay, so first of all you can simply make your collection and then just create this function, same function you can create. Okay, so now this function simply connect with your collection. This is my collection data, then it will be work. So now how I can connect, so you can see. So for that I take the another variable, suppose put the variable name is that, suppose final CSV. Okay, so now I just simply call my collection. So what is my collection? Collection is the 410 images, and it is stored in a variable data. Simply copy the data and paste here. Okay, now use a function, map function, and then call the function variable name CSV. Simply copy the variable name CSV and paste here. So now it connect with my image collection. Okay. So now if you want to check about that, simply use that print function, and I check the result about that, what type of result I can get from here. So just print that. Okay. Okay, so here I can get the result. Click on here. So you can see the feature 410, or 410 images. In this time, click on here. Click on here. Okay. In this time, you can see this time 2020 1st January, and also including the time. Okay. In this time, the you can see what is the value. In this time there is a null. Okay, so in this time I did not take any, it not extract any types of pixel value. Okay, 1st January, suppose this time. Okay, there is the no value, it not extract the any value. So I want to check the another, suppose check the, you can see it also, yeah, it also 1st January but another time, different time. And in this time what happened, you can check. Also now there is a no value about that. Check the another. So this time 1st January, also null. This time period, you can check the value. Yeah, in this time we can get the value. So you can see basically this air quality, this type of data we can access also time wise. Okay, so 1st January, you can see 1st January, I access the data in this time. Okay, 6:8:51 second. Okay, I can get this data. And other you can see there is the no data, so that's why it's showing the null value. Okay, so also you can check about that. Suppose what is the condition about that. Suppose you can see 1st January, it is the 8:21 second. So simply click on here, also null about that. Okay, so in this time it also provides the data set as a time wise. Okay, time wise we can get the data. So that's why you can see we can get the 1st January lot of time, but 1st January which time I get the data. Okay, so in this time I simply export the data and check in the Excel file, then it's better. So for that I can simply use the function export table to track, and put all of those things one by one. So make a dictionary, curly bracket start. That's a curly bracket in. And then first of all collection. Collection is that our, in this time, final CSV. Simply copy and paste. Description, you can put any name, such as I put the name such as NO2. You can put any folder. Suppose I put the folder name is that G. You can put any folder name. File name not need, it's not need, simply that. In this time file format is name. Okay, I put the file format is that CSV. Okay, and after that selector is also need. Okay, so selector mainly is the column name. Okay, in your column name will be, just put here the date, and another column will be stat. And it's not anything like that. Okay, so now click the run. Our task will be running. So simply click on the task, and from here just click the run. Yeah. So now you extract all of those data in CSV file format.